Imagine, for a moment, that you are drifting in the silence of space, watching something turn slowly beneath you, something blue and white and infinitely patient. You are watching Earth complete one rotation, watching sunlight slide across continents and oceans as it has done, reliably and without fanfare, for more than 4 billion years. And as you drift there in the weightlessness and the quiet, you begin to notice something strange. Nothing about this ancient world seems hurried. Nothing seems anxious. Even from this vast distance, even from this perspective where mountains become invisible and storms dissolve into soft swirls of cloud, Earth radiates a peculiar kind of peace, the peace of something that has learned, over almost incomprehensible spans of time, how to simply be. We live on a planet so rare, so precisely balanced, so quietly extraordinary, that scientists studying thousands of distant exoplanets across the galaxy still struggle to find another world quite like it. And yet most of us move through our days scarcely noticing. We do not pause often to consider that our home has survived cosmic collisions, that it has cooled and stabilized and learned to hold life in an embrace so tender that a single bacterium, given the right conditions, can flourish. We forget that Earth itself is a story, a slow, unfolding narrative of becoming that stretches back to silence and dust. If you have ever felt your breathing slow when looking at the ocean, or found yourself strangely comforted by the thought of deep geological time, or wondered what it might feel like to understand Earth not as a resource to be used, but as a living presence to be witnessed, then you will want to stay with me. Please subscribe to this channel so that we can continue exploring together the most relaxing facts about Earth, the quiet truths that remind us why our world has always been, and may always remain, the gentlest sanctuary we will ever know. Now, let us turn our attention backward, far backward, to a time before Earth existed at all. 4.6 billion years ago, in a region of space that would one day become home to our solar system, there was only a vast, slowly rotating cloud of dust and gas. Astronomers call this a protoplanetary disk, though the name, technical as it is, hardly captures the dreamlike quality of what was actually occurring. Imagine a spiral of infinitesimally small particles, all drawn together by gravity's patient, invisible hand, all caught in a rotation so gradual and so enormous in scale that it might have seemed, to any consciousness observing it, less like motion and more like breathing. The particles were cold, scattered across a region of space larger than our entire solar system. They collided with one another, gently at first, then with increasing intensity as the disk grew denser, as gravity's pull became more insistent. And slowly, through countless collisions, through a process that would take not days or decades but millions of years, these particles began to gather into larger and larger bodies. This process, called accretion, is one of the most profound and patient mechanisms in the universe. It is violence, yes, but it is violence in slow motion. It is countless tiny impacts, each one releasing a fraction of heat and energy, each one causing dust grains to stick together into pebbles, pebbles into boulders, boulders into increasingly massive protoplanets. There is something almost soothing about understanding it this way, is there not? The birth of worlds was not instantaneous. It was not some sudden explosion of creation. It was, instead, a gradual accumulation, a gentle gathering, a cosmic process that took patience and time, the two most abundant resources in the universe. Earth, during these early millennia, was not yet the blue marble we know. It was not yet solid or cool or fit for life. It was, instead, a growing planetary embryo, a swelling mass of rock and metal, heated by the constant impacts of infalling material, by the slow compression of its own weight pressing down upon its center. And as it grew larger, and as more and more material accumulated onto its surface, something remarkable began to occur. The heat from all those ancient collisions began to accumulate. The pressure at Earth's core began to intensify. The planet, in its infancy, was literally being born from fire. And in that fire, in that ancient world-building heat, lay the seeds of everything that would follow. There is something profoundly settling about learning the true story of where you are. Not the facts alone, but the way. They unfold across time, each discovery resting gently upon the last, like sediment layering into stone. If you found yourself drawn into this quiet exploration of Earth's deepest history, if the thought of our planet's patient becoming feels like a kind of companion to your own breathing, then you might find comfort in journeying with us through more of these slow revelations. We create these narratives specifically for those moments when you wish to know something real and beautiful about the world before sleep takes you. Stories that honor both the precision of science and the wonder of simply being alive on a turning sphere of rock and water. Each piece of Earth's story unfolds differently, each one a thread in an immense tapestry that's been weaving itself for billions of years. If you'd like to receive these gentle documentaries as we release them, as a way to drift into sleep while your mind rests in genuine knowledge, consider subscribing to follow Earth's quiet cosmic story with us. We'll be here, waiting to guide you through the slowness of deep time, the steadiness of planetary motion, the invisible forces that have held this world in balance since before any living thing could witness it. Now, let us move deeper still into that beginning, that moment, if we can even call it that, when Earth was not yet Earth, when there was only the memory of a star that had already died, its scattered remains spiraling through the cold dark, drawn together by gravity's patient pull. 4.5 billion years ago, before even the oldest rocks existed, before there was a sky or an ocean, there was only dust. Infinite, slow-drifting dust, mixed with gas and the atomic residue of ancient stellar explosions. This is how planets are born, not with force or drama, but with an almost imperceptible gathering, particles touching other particles, drawing others near, building in silence across millions of years until something substantial began to form. The process is called accretion, a word that carries within it the feeling of gradual accumulation, of one small thing adding to another until a presence emerges. In that swirling disk of solar material, our sun had already ignited at the center, its gravity dominating everything around it. And yet, in the quieter regions farther out, smaller centers of growth began, planetesimals, rocky fragments ranging from dust specks to boulders many kilometers across, drifted together, colliding not with violence, but with the gentleness of slow-moving bodies in the vast emptiness. Each collision increased a young protoplanet's mass, each merger drew in more material, and gradually, inexorably, the early Earth took shape. Can you picture it? A world forming not through explosion, but through the soft arithmetic of gravity, each grain of dust finding its place, each rock contributing its weight to a growing whole. The early Earth was not stationary. It was surrounded by a cloud of remaining debris, a swirling envelope of material that would continue to feed it, to shape it, to define it. The warmth building within this growing sphere came not from any external heat, but from the friction of all these collisions, from the compression of so much mass being drawn inward, creating pressure and temperature that accumulated day after day, year after year, millennium after millennium. This violent accumulation sounds chaotic, and by some measures it was, and yet there is something deeply calming about understanding that it happened at all, that the mathematics of gravity and the patience of geological time can assemble worlds. The collisions were not quick. Nothing about planetary formation is quick. The timescales are so vast that if we were to watch them unfold, we would see only stillness, only the slow turning of dust clouds, the gradual thickening of a sphere, the gradual brightening of a newly forming world as internal heat began to glow faintly from within. The young Earth, perhaps 50 to 100 million years into its formation, was already recognizable as Earth, a sphere of rock, still mostly molten at its surface, still surrounded by the remnants of the planetary nebula that had birthed it. At this stage, it bore little resemblance to the world we know. There was no atmosphere as we understand it, no oxygen, no nitrogen mix, only the outgassing of the planet's own interior, releasing volatile compounds into the void. There were no continents, no oceans, no distinction between what was rock and what might become sky. There was only a world in process, still assembling itself, still learning what it would become. And somewhere in this forming solar system, at a distance of perhaps 4 or 5 planetary radii away from the young sun, the early Earth continued its slow dance, spinning in the dark, drawing material unto itself, growing warmer, growing denser, growing more substantial with each passing age. The details of this formation, the precise mechanics of how our planet coalesced from cosmic dust, remain one of the gentlest mysteries of science, not because we lack understanding, but because what we understand is so vast and so gradual that it inspires something like awe. It took patience beyond human comprehension. It took time measured in the patient beating of deep geological clocks, and the result, billions of years later, is the world beneath your feet, the platform upon which all of life has arisen, the rare and singular sphere that hosts every story ever told, every being that has ever drawn breath. 4.5 billion years ago, in a corner of our galaxy that held nothing yet, there existed only a vast cloud, a nebula, astronomers call it now, a swirling, turning expanse of dust and gas, so enormous that it seemed to contain the entire future within its slow rotation. The particles were impossibly small, scattered across distances so great that light itself would take years to cross them. Yet within that emptiness, something was beginning. Gravity, that gentlest and most patient of all forces, was quietly at work. It pulled and gathered, drawing each grain of dust and molecule of gas toward a center that didn't yet exist. The cloud began to turn faster, collapsing inward under the weight of its own being. Imagine a slow waltz, if you will, a dance where millions of years pass in what feels like a single moment. The nebula spun tighter, denser, warmer. Friction between particles created heat. The gas began to glow. This is where the solar system was born, not with sudden violence, as the old stories suggested, but through a gradual gathering. Dust clumped together in the swirling disk, pebbles collided and stuck. Rocks formed from these patient unions, and over millions of years, a span of time so vast it stretches the human mind, these rocks grew into planetesimals. Kilometer after kilometer of accumulated matter, each collision adding substance, each merger creating something slightly larger, slightly more real. The early solar system was not quiet. There is something important to know here. What we might call the gentle violence of accretion was still, in human terms, tremendously violent. Worlds were colliding. Asteroids struck at speeds we can barely fathom. Yet when we imagine it from the perspective of geological time, from the vast patience of physics itself, it feels almost like a slow breathing, objects drawn together, merging, settling into a new form. A protoplanet grew, where our Earth would eventually rest. One of these early worlds, a body perhaps the size of Mars, though the details remain softly uncertain, collided with the proto-Earth around 4.5 billion years ago. This is a story we'll return to, but for now, know that Earth was still gathering itself, still accreting, still becoming. Each impact added mass. Each merger brought more material from the solar system's nursery, and with each addition, Earth grew heavier, denser, more capable of holding on to what fell upon it. The young Earth, in these early days, was not the serene blue sphere we know. It was hot. Its interior was kept warm by the constant rain of impacts, by the compression of all that accreting matter, by the slow decay of radioactive elements trapped within its forming body. The entire planet was likely molten, or at least partially liquid, a landscape of glowing stone, of magma oceans, of a world still in the process of determining what it would become. And yet, even in this seeming chaos, there was order. The heavier elements, iron, nickel, sank toward the center, drawn by gravity toward the planet's heart. The lighter materials rose toward the surface. This process, called differentiation, was itself a kind of settling. Earth was organizing itself, layer by layer, into the structure it would maintain for billions of years hence. A dense iron core at the center, wrapped in a thick mantle of hot stone, topped by a thin, delicate crust that would one day crack and shift and dance across the surface. Consider what was happening in those early millions of years. Countless objects, each carrying its own bit of cosmic material, finding their way to the same place in space. Water, perhaps, locked away in the bodies of asteroids and comets, fragments of the solar system's outer reaches that spiraled inward, carbon compounds, the raw materials of chemistry that would eventually become life. All of it was being gathered, accumulated, becoming part of something new. Slowly, gradually, imperceptibly to any observer who might have existed, the rain of material began to ease. The solar system was clearing. The protoplanetary disk was emptying. The large objects, the planets, had formed, and the smaller debris was either incorporated into them, ejected into space, or sent into stable orbits around the young sun. Earth's accretion was slowing. The bombardment, while still significant, was becoming less intense. And as this cascade of collisions diminished, something profound began to happen. The young Earth, still incredibly hot, but no longer being bombarded every moment, began to cool. Not quickly, patience was still the rule here, spans of millions of years, but perceptibly, the surface, exposed to the near vacuum of space, began to solidify. The molten magma ocean developed a thin, brittle skin. Earth was acquiring a crust. This transition from accretion to stillness, from constant gathering to a kind of completion, carries a peculiar kind of peace when contemplated from a distance. The universe had brought together, over the course of 5 or 10 million years, all the material that would ever form this planet. It was done now. Earth was complete in its basic composition. What remained was not formation but transformation. The planet could now begin the slow, deep work of becoming the world that would, eventually, harbor life. What you're hearing in this story is not the history of violence that older textbooks once emphasized, but rather the patient logic of physics and chemistry solving the puzzle of planetary birth. Each collision was both an ending and a beginning. Each merger was both destruction and creation. And through it all, through 4.5 billion years of cosmic time, the Earth was slowly, gently, inexorably becoming itself, the home that it would turn out to be. Perhaps 4.5 billion years ago, in the young solar system's crowded neighborhood, something extraordinary happened. Something that would fundamentally reshape our world, and yet it feels, in retrospect, almost like a dream. Imagine our proto-Earth, perhaps 80 or 90% formed already, still warm and restless from its own assembly, still collecting the final debris of its neighborhood. The solar system in those early days was not the orderly, spacious place we see now. It was fuller, it was messier. Planets and protoplanets jostled and collided and migrated through a haze of dust and rock that we are only beginning to fully understand. Into this scene, and here we drift into what planetary scientists call a giant impact hypothesis, a theory so elegant and so well supported that it has become almost consensus truth, came a Mars-sized object. Some call it Theia, a name borrowed from Greek mythology, the Titaness who embodied light. Perhaps it is fitting. This planetary embryo, maybe the size of Mars, maybe slightly smaller, had been orbiting in the chaotic early solar system for millions of years, and its trajectory was about to intersect with Earth's own. What happened next was catastrophic, and yet we speak of it now with a kind of awe, as if recounting a moment of terrible beauty. The impact itself, when Theia collided with the young Earth, would have released an unimaginable amount of energy. Imagine the sound of it, if sound could travel through the vacuum of space. But of course it could not. It happened in silence, a silence more profound than any silence we know. The collision did not destroy Earth. Instead, something remarkable occurred. The impact was oblique, that is, Theia did not strike Earth head-on. It came at an angle, a glancing blow that would have sent both bodies spinning, vaporized a portion of the impacting object and a portion of Earth's outer layers, and sent that material, a vast cloud of vaporized rock and metal, into orbit around the wounded Earth. And from that orbiting debris, slowly, over the course of months or perhaps years, the moon accreted. The moon formed from the wreckage of a collision, and yet there is something almost serene about contemplating this origin. The moon, born from catastrophe, yet becoming one of the most stabilizing, most calming influences on our world. Do you ever wonder why the moon hangs so perfectly in our sky? Why its pull is so precise, so gentle, yet so consequential? Part of the answer lies in that ancient impact. For Theia did more than create the moon. The impact also transferred a tremendous amount of angular momentum to Earth, causing our planet to spin faster than it might otherwise have done. This greater spin rate, this faster rotation, it would have had profound consequences. And here is where the deeper magic unfolds. As Earth settled after the impact, as that orbiting debris gradually condensed into the moon began to exert its gravitational influence on Earth. It still does. The moon pulls on the oceans, creating tides. The moon's gravity subtly acts upon Earth's entire body. Over time, and we are speaking of billions of years, the moon has been slowly migrating outward, away from Earth. As it does, it exerts a brake on Earth's rotation, gradually slowing it down. Days grow imperceptibly longer. But here is the essential thing. The moon's presence has kept that rotation steady. It has prevented chaotic wobbling. It has kept Earth's axis tilted at a relatively stable angle. This stability and tilt is profoundly important. Earth's axial tilt, that 23.5-degree angle relative to the plane of its orbit, is what gives us seasons. It is what creates the rhythm of warm and cool, of growth and dormancy, of light and shadow that all life has come to depend upon. But without something to stabilize that tilt, without a massive companion moon to anchor Earth's rotational momentum, our planet's axis might oscillate wildly. Imagine a world where the tilt varies chaotically, one age where it tips to 30 degrees, then to 15, then to 40. The climate would convulse. The seasons would become unpredictable and violent. Life as we know it could scarcely have emerged, much less flourished. And so we owe our stability, our mild seasons, our temperate rhythms, the very framework upon which all terrestrial life has evolved, to that distant, dreamlike collision. The giant impact was, in a sense, the moment when Earth's destiny became secure. Not because Theia's collision itself was gentle, but because what it created, the moon, has been tenderly, persistently holding our world in balance ever since. The moon, then, is not merely a distant ornament in our night sky. It is Earth's steadying hand. It is the ancient gift of a collision so long ago that we can barely fathom it, rendered into something that feels now as constant and reliable as breath itself. The Earth, in those first hundreds of millions of years after the great collision that birthed the moon, existed in a state that would seem utterly alien to us now. A glowing sphere of molten rock, its surface a churning ocean of liquid silicate and iron, temperatures reaching perhaps 1200 degrees Celsius or more. Yet even in this apparent chaos, something deeply quiet was already unfolding. The heavier elements, iron and nickel, were slowly sinking toward the center, drawn down by their own weight in a patient, inevitable descent, while lighter rocks rose and cooled in the thinnest upper layers. This process, called differentiation, took place over vast stretches of time, not in the violent rush we might imagine, but as a gradual sorting, a gentle separation that would eventually give Earth its layered structure, its dense metallic core, its rocky mantle, and the fragile crust upon which we stand. As the eons passed, something remarkable began to happen on the surface. The endless rain of meteorites and asteroids gradually slowed. The cosmic bombardment that had shaped the young solar system was beginning to ease, and in that quieting, the infant Earth started to cool. Picture, if you can, a world still radiating tremendous heat from within, yet slowly, molecule by molecule, shedding that heat into the void of space. The outermost layers began to solidify, forming what we might call a crust, though it was far thinner and more unstable than the crust we know today. It was thin like the skin forming on cooling milk, and just as fragile, constantly breaking and reforming as the hot material beneath pushed upward and the cooling material above sank down. There were no continents yet, no stable foundation for mountains or plains. There was only this dark, half-molten surface, punctuated by countless volcanic vents, releasing gases that had been trapped deep within the young planet. And what gases those were! Hydrogen, helium, nitrogen, and carbon dioxide poured from the Earth's interior, released by the heat and the pressure of all that molten rock. There was ammonia and methane too, compounds we associate now with decay and swamps, but which at that time were simply the breath of a planet still in the process of becoming. The Earth, in those earliest ages, was exhaling. These gases accumulated above the surface, forming an atmosphere, not the oxygen-rich air we breathe, but something altogether different, something that would have been poisonous to any modern life. Yet it was an essential step, a necessary stage in the long, patient journey toward habitability. The atmosphere was being built, layer by invisible layer, from the planet's own interior. But the most crucial element for life, the one that would eventually allow oceans to form and life itself to emerge, was already present in that early atmosphere in trace amounts. Water. Where did it come from? Some of it had been locked away in the rocky material that accreted to form the Earth. Some, perhaps, arrived on comets and asteroids that struck the young planet. The question of precisely how much water came from which source remains one of those beautiful mysteries that scientists are still gently unraveling, a puzzle that invites curiosity rather than demanding certainty. What we can say with confidence is that water vapor was present, mixed with all those other gases, swirling in the hot, alien sky above the cooling crust. As the Earth continued to cool, and this cooling took place over millions of years, an enormous stretch of time by human standards, yet merely a moment in cosmic reckoning, the temperature of that early atmosphere began to drop. Slowly, inexorably, the water vapor, which had been a gas, a thin presence in the air, began to condense. Can you imagine it? The first rain, not the gentle, life-giving rain of the present day, but something far more dramatic, torrential downpours that lasted for millennia, perhaps even for longer. Countless millions of years of water falling from the sky, accumulating in the low places on the still-forming surface, pooling and gathering, and settling into what would become the first oceans. It would have been like watching a slow-motion waterfall that never ended, a patient precipitation that gradually filled the basins of the planet. Some of this water may have come from the atmosphere. Some may have emerged from the very rock itself, released as that deep heat drove chemical reactions in the planet's interior. What a strange and wondrous sight that would have been, if anyone could have been there to witness it. The barren, dark crust, slowly being covered by waters that had fallen from the sky. The shorelines forming and reforming as the water level rose, the temperature fluctuating as massive amounts of water drew heat from the hot rocks beneath, cooling them further in return. There is a subtle poetry in this process, a rhythm that feels almost musical when you contemplate it slowly. The Earth, still volcanic, still radiant with interior heat, was slowly becoming a water world. The oceans were not born in a moment, but rather condensed into existence over an almost unimaginably long period, perhaps 200 million years or more of continuous rain. By the time that torrential age had ended, perhaps 500 million years after the moon-forming impact, the Earth had begun to resemble something we might recognize, a blue-grey sphere covered largely by water, with patches of dark volcanic rock poking above the surface, surrounded by steam and clouds. Those ancient oceans were not empty. They were chemically complex, filled with minerals dissolved from the cooling rocks, salts accumulating in their depths. They were warm, heated by volcanic vents on the ocean floor and by the planet's residual interior heat. They were different from the oceans we know, different in composition, different in temperature, different in character. Yet they were oceans nonetheless, and in their depths and shallows, as we will explore in the passages ahead, the first stirrings of what would eventually become life were already beginning to take shape. And so the surface began to settle. The bombardment of asteroids and comets that had rained down through those first 100 million years slowly, gradually, came to an end. The great collisions ceased. The planet stopped trembling quite so violently. And in this relative calm, this deep, patient lull that would stretch across hundreds of millions of years, something remarkable began to happen. Water arrived. We do not yet know the complete story of where Earth's water came from. Perhaps it had always been locked within the planet, bound into the minerals and rocks from which our world was born. Perhaps it came riding on the backs of comets from the outer solar system, icy travelers that had crossed the vast dark. Perhaps it arrived on the countless meteorites that continued to fall, still falling, even as the great age of collision quieted. Some water likely came from all these sources at once, and for now, it matters less where it came from than what it did when it arrived. As the crust cooled enough to allow it, this water began to condense. Imagine steam rising from an immense ocean of liquid rock. Imagine that steam rising higher and higher into the atmosphere, accumulating in clouds so thick that no sunlight reached the surface below. And then, ever so slowly, as the crust continued its patient cooling, that steam began to fall. Rain. Soft, patient rain. Rain that fell for thousands of years. Rain that fell for tens of thousands of years. Rain that fell for hundreds of thousands of years. All of it gathering in the low places, in the vast basins of the newly formed crust, filling them deeper and deeper with water, fresher water, water that had not yet been touched by the minerals of the stone beneath. This was not the rain of a summer afternoon. This was the rain of a world being born, gentle and relentless, falling from skies that were still thick with gases and dust. And as it fell and gathered and pooled, the first oceans took shape. Not the clear blue oceans we know today, but ancient seas that were perhaps tinged with different colors, influenced by the minerals in the air and the young crust beneath. These oceans grew deeper, they grew wider, and with each year that passed, with each century and each millennium, the world became less a place of fire and smoke and more a place of water and stone. The atmosphere too was transforming, though the changes were so gradual, so subtle, that if you had stood on the surface during any single year, you might not have noticed anything at all. Yet over the span of millions of years, The composition of the air itself was shifting. Slowly, the water vapor that had been so thick in those early skies was beginning to condense out, to fall as rain, leaving the atmosphere less dense, more clear. The carbon dioxide that had dominated the early air, greenhouse gases that had kept the young Earth warm even under a dimmer sun, was beginning to dissolve into the oceans, where chemical reactions with the water and the rocks would eventually lock much of it away. This was the world learning to breathe, learning to exhale in a new way. The great volcanic outgassings that had released these gases from deep within the planet during its violent youth began to settle into a rhythm. Volcanoes still erupted, still would erupt for eons, still erupt today, but they were no longer the sole voice speaking to the atmosphere. Other processes had begun: chemical reactions, geological cycles, the first hints of something that would eventually become life itself, and through life, a completely new way for the atmosphere to change and reform and stabilize itself. The early oceans, though they covered most of the world just as our oceans do now, were not like the seas we know. They contained different salts, different dissolved gases, a different chemistry altogether. Yet, even in this alien composition, there was something deeply settling about them, something profoundly calm. They were, for the first time, stable. The world had stopped convulsing. A rhythm had begun to establish itself. Days and nights followed one another. Seasons turned, though we cannot be certain what those ancient seasons were truly like. Rain fell and filled the seas. Evaporation rose and fell. The hydrological cycle, that great loop of water that connects sea to sky to land and back again, was beginning its eternal dance, even in these early, ancient times. And the atmosphere, too, was finding a kind of equilibrium, not a perfect equilibrium, not yet. The changes would continue for billions of years. But something had shifted from chaos toward order, from violence toward quietude. The temperature, regulated by those thick greenhouse gases and by the balance of energy coming from the sun, began to fall within a range that would allow liquid water to persist, not icebound, as the entire world would become at times in the deeper future, but not so hot that all the oceans would boil away. A gentle middle ground had been found. What does it feel like to imagine a world in this state? A planet with vast oceans under thick, dark skies, a crust of stone and minerals slowly cooling, volcanoes releasing gases that would become the air itself. No colors as we know them, not yet. No green forests, no blue sky. And yet there is something profoundly peaceful in this image, something deeply restful about a world in the process of learning how to be alive. The violence had not ended. It would never truly end, but it had become slower, more patient, more rhythmic. The world was exhaling. It was settling. It was, for the first time in its existence, beginning to be a place where something could eventually live, could eventually grow, could eventually look up at the stars and wonder at its own existence. And so, as those ancient oceans settled into their basins, as the first rains fell upon new stone, something invisible began to stir deep within the planet itself. At Earth's core, in chambers of iron and nickel hotter than the surface of the sun, a gentle current was beginning to flow. This was not water, not wind, but something far more subtle and profound. The birth of Earth's magnetic field, that invisible guardian that would hum quietly around our world for billions of years to come. Picture, if you will, the inside of our planet. Beneath the crust, beneath the mantle's slow-churning rock, lies the outer core, a realm of liquid iron and nickel, swirling in patterns that no eye has ever seen, following laws of physics and heat that scientists are still, even now, learning to read. When molten iron moves, it carries with it the ghost of electrical charge, and moving electricity creates magnetism. This was Earth's first breath of invisible protection, a field beginning to curl and stretch around the planet like a lover's gentle embrace. The solar wind, that constant, invisible stream of charged particles flowing outward from the sun, has been pressing against every world since the solar system's birth. On worlds without shields, on Mercury and the Moon and Mars, these particles rain down without mercy, stripping away atmosphere, scouring the surface, leaving behind only silence and stone. But Earth, in those crucial first millions of years, was being protected. As the sun's wind pressed inward, the magnetic field pushed gently outward, and between them formed an invisible boundary, a realm scientists would one day call the magnetosphere. Can you imagine standing on the ancient Earth, in those early epochs, feeling the faint hum of this shield above you? Of course, no human was there to feel it. No ears existed yet to hear the frequencies of magnetism singing through the air. But the field was real, was growing stronger, was learning its geometry and its rhythm. The molten iron at the core continued its patient swirling, and with each rotation of the planet, with each convection current rising and falling in that lightless realm beneath our feet, the field was refined, strengthened, made more intricate. The magnetosphere is not a simple solid thing. It is layered, complex, shaped by forces we are still mapping. The solar wind pushes on one side, compressing the field into a teardrop shape, stretching it out on the opposite side in a long tail that reaches far into space. On quiet days, the field holds firm. On stormy days, when the sun releases a coronal mass ejection, a great bubble of plasma rushing outward, the magnetosphere shivers and dances, adjusting itself like a living thing. The field bends but does not break. It absorbs the impact, dissipates the energy, and continues its ancient work. And what is that work, truly? It is an act of profound generosity, a protection so complete that life itself depends upon it. The magnetosphere shields the upper atmosphere from the solar wind, preventing the slow stripping away of our air molecule by molecule. It channels dangerous particles, protons and electrons and heavier ions, down toward the poles, where they spiral along the field lines in a gentle, descending waltz. When these particles collide with the gases of the upper atmosphere, they release their energy in a burst of light, and that light is what we call the auroras, the northern and southern lights, those dancing curtains of green and red and violet that have moved the hearts of countless observers on cold, dark nights. One might wonder, how fragile is this shield? Could it fail? Scientists have evidence that it nearly did, or perhaps temporarily did, at times in Earth's past. The magnetic field does not maintain a constant strength. It fluctuates on timescales of millennia and longer. Every few 100,000 years, the field goes through a reversal. The North Pole becomes south, and the south becomes north. These reversals are not instantaneous. They take centuries or even thousands of years to complete, and during that transition, the field grows weaker. There is a moment of vulnerability, a moment when Earth's shield thins. But even during these reversals, the field does not disappear entirely. It becomes more complex, more layered, as if Earth itself is taking a slow, deep breath and exhaling in a new direction. We know this from reading the rocks. In the cooled lava flows and in the cores of sediment drawn from the ocean floor, magnetite crystals have locked in place the direction and strength of the field at the moment they cooled. Geologists can read these stones like a library of Earth's magnetic memory, and the record is clear. The reversals have happened countless times, and life has endured through every one. The field has always returned, always reformed, always resumed its patient guardianship. What draws the molten iron in the core to move in these great currents? The answer lies in heat, in the slow decay of radioactive elements deep within the planet, in the residual warmth from that ancient collision that formed the moon, still slowly radiating outward even after billions of years. Heat rises and cooler material sinks, and this convection continues without pause or rest, turning the liquid iron, driving the dynamo, maintaining the field. It is motion born from the planet's own slow metabolism, from processes so vast and ancient that they dwarf human time entirely. And so we exist within this magnetic cocoon, though we rarely think of it. Your own body is not magnetic, or rather, not notably so. But the birds that navigate thousands of miles, they feel something we cannot. The sea turtles that swim across oceans, the whales that migrate in their great, circling patterns, the insects that respond to the Earth's field, they are embedded in this invisible geography. The magnetosphere is as much a part of our world's character as its water or its air. Yet most of us go through life never consciously acknowledging its presence. The field is strongest near the poles, where the field lines converge and dive down into the Earth itself. It is weaker at the equator, where the field lines are more spread out. And so there is a gentle gradient to this shield, an asymmetry that has likely influenced the patterns of life itself, the currents and migrations, the ancient routes taken by creatures long extinct and by creatures living still. The magnetosphere has not merely protected life, it has shaped it, guided it, and influenced the very pathways that evolution has taken. Even now, billions of years after its formation, Earth's magnetic field continues its silent work. It continues to turn aside the solar wind, continues to glow with auroras at the poles, continues to guide migrations, and to protect the upper atmosphere from the slow erosion that would otherwise occur. It is one of the great quiet miracles of our world, a miracle born from heat and motion and the fundamental laws of electromagnetism, humming endlessly in the darkness, asking for nothing in return. And beneath the thin skin of solid crust that now held water and air, something far grander was stirring. The Earth's surface, you might imagine, was finished, a settled, permanent stage upon which life would eventually arise. But the planet had other rhythms in mind, older and slower than anything that would walk or swim or fly across its face. These were the rhythms of the very ground itself, the patient, almost breathing movement of the continents that still continues in this very moment, so slowly that we scarcely feel it, and yet so persistently that it has remade the entire face of the world over and over again. The crust upon which we stand is not one unbroken shell. It is broken into vast sections, each one a tectonic plate, and these plates are floating, with extraordinary gentleness, upon the warmer, more fluid rock beneath them. They drift, they slide past one another, they collide in slow motion and pull apart, and in doing so, they carry entire continents across the face of the ocean. This was not always understood. For centuries, the continents appeared fixed, unmovable, as though they had always been precisely where they were found. But in the early 20th century, a scientist named Alfred Wegener noticed something remarkable, that the continents fit together like puzzle pieces. Africa and South America, when drawn carefully, seemed to have once been neighbors, and when the fossils of the same creatures were found on opposite sides of vast oceans, separated by distances that seemed impossible to cross, the question became unavoidable. Had these lands once been joined? They had. And they drifted apart not in the violent, catastrophic rush of imagination, but in a movement so slow that it took decades of careful measurement to prove it was happening at all. The continents move at the speed of fingernails growing. Your fingernails, growing at perhaps 3 millimeters per week, move faster than the fastest moving tectonic plates on Earth. And yet, given hundreds of millions of years, incomprehensibly vast stretches of time, this gentle drifting has separated land masses that once lay together, has created the Atlantic Ocean as it stands today, has opened up new seas and closed off others. The process is ongoing. As you rest, North America is drifting westward at a speed of about 2 to 3 centimeters per year. Europe and Africa are being pulled apart by the rifting of the Atlantic floor. Australia, that isolated continent, continues its ancient journey away from the others, and in the vastness of deep time, these movements reshape everything. The mechanism behind this drift is itself soothing to contemplate, once you understand it. The Earth's interior is hot, far hotter than the surface, closer to the temperature of a furnace. This heat cannot escape directly through the thick crust. Instead, it rises in enormous, slow-moving convection currents. Imagine a pot of honey being gently heated from below, the honey itself beginning to turn over and over in great, invisible circles. The plates of Earth's crust are carried along on these currents as though they were leaves floating on an unimaginably slow river. Where the currents rise toward the surface, they push the crust upward and apart, creating mid-ocean ridges, those underwater mountain chains that girdle the Earth like the seams of an ancient sphere. Where the currents descend, they drag the crust downward, in zones called subduction zones, where one plate slides beneath another and returns, over millions of years, to the interior from which it came. And in between, the plates shift and grind, creating the boundaries where earthquakes occur, where mountains are born, where the geography of the world is constantly, imperceptibly being rewritten. This is not violent on a human timescale. An earthquake is violent to us, yes, but it is only the occasional, sudden release of pressure that has built up over centuries or millennia of steady, imperceptible motion. Between these releases, the movement is continuous and utterly gentle, so smooth that no instrument in your body could detect it. Imagine pressing your hand against a car as it rolls at 1/100th of an inch per second. You would feel nothing. You might never know the vehicle was moving, and yet after enough time, after days, it would be far away. This is how continents move across the Earth. The rhythms of plate tectonics operate on timescales that dwarf human history, human civilization, human memory. 200 million years ago, all the continents were united in a supercontinent called Pangaea. It lay there, whole and connected, as Africa and Europe and North and South America and Asia and Australia and Antarctica were all clasped together like the parts of a sphere coming together in sleep. Then, gradually, persistently, the drift began. The continents were pulled apart, scattered. Pangaea fragmented into Laurasia and Gondwana, which themselves broke apart, and the pieces scattered further still. The continents began their long migration to their current positions, a journey that is still, even now, incomplete. In another 100 million years, the continents will not occupy the same positions they hold today. Africa is moving northward, eventually to collide with Europe, and the Mediterranean Sea will vanish. Australia is drifting toward the equator. The Americas will, over vast spans of time, move westward still. The map that seems so fixed and permanent to us is only a single frame in an enormously long film. And in this slow movement, in this gentle, breathing rearrangement of the continents, we find a kind of peace. There is something deeply calming about the idea that the world beneath our feet is not rigid and unchanging, but rather fluid in its slowness, constantly reshaping itself according to forces that have no intention, no hurry, no agenda. The continents have not collided in anger or rushed to their destinations. They have simply moved, as they must move, as the heat within the earth compels them to move, and in moving, they have created the world we inhabit. Every mountain range is a record of this slow dance. Every ocean basin is a scar left by the drifting. The Himalayas stand where India, once an island, collided with Asia, a process that began tens of millions of years ago and continues even now. The Andes rise from the subduction of the Nazca Plate beneath South America, a process of gentle but persistent pressure applied over millions of years, reshaping stone into peaks. This is not a violent rearrangement, though we often forget it. Yes, Earthquakes shake the earth. Yes, volcanoes erupt along the plate boundaries, but these are spasms, sudden releases of pressure, the equivalent of a sigh in a continuous breath. The real movement, the fundamental rhythm, is smooth, persistent, and so slow that it barely qualifies as motion at all. It is the earth breathing, expanding and contracting over millions of years, rearranging the continents as though they were pieces on a board that time itself is playing with infinite patience and no rush. There is deep comfort in this understanding. The world is not still, and yet it is never hurried. The earth is in constant motion, and yet this motion is so gentle that we feel secure, standing on its surface. The continents are drifting, and we are drifting with them, and we will never notice, and generations upon generations will be born and live their entire lives upon stones that, over the vast arc of time, are slowly traveling to new homes, creating new configurations of land and sea, reshaping the stage upon which life performs its infinite variations. This is the breathing of the earth itself, and we are held safely within each breath. And there, orbiting just 250,000 miles away, is the moon, our singular satellite, locked in a slow gravitational embrace that has shaped not merely the oceans of Earth, but the very rhythm of life itself. If you have ever stood by the sea at night and felt the pull of something ancient and powerful drawing water up toward the stars, you were feeling the moon's hand upon the world. This is not metaphor. It is physics rendered as poetry, as real as the ground beneath you. The moon tugs at Earth with a quiet, relentless force. Every day, as our planet spins and the moon circles overhead, vast bulges of ocean water swell toward it. Two great tides, one facing the moon and one on the far side of Earth, rise and fall with a rhythm that has been unbroken for billions of years. Every coast, every inlet, every tide pool knows this ancient metronome. The water does not choose to rise and fall. It simply obeys a law written in gravity itself, pulling, releasing, pulling again, as though the moon were breathing and the oceans were breathing with it. But consider what this means. Over 4 billion years, as life first emerged in those ancient oceans, the tides were there. The rhythmic flooding and draining of coastal waters created pools of infinite variety, chambers where the chemistry of life could be experimented upon, tested, refined. The tides mixed fresh water with salt. They brought nutrients from the deep. They exposed and concealed, challenged and sheltered. The earliest organisms did not need to seek these rhythms out. The rhythms found them. The moon's gravity wrote the schedule upon which the very first life learned to keep time. And as life grew more complex, it never forgot. Move forward hundreds of millions of years, and you will find creatures attuned to the tides with a precision that seems almost magical. Horseshoe crabs emerge from the sand on the exact night of the highest spring tide to lay their eggs, reading the moon's position in their blood, as surely as you might read a calendar. Grunion fish in California's shallow waters follow the same invisible clock, arriving at beaches during the highest tides to spawn in the wet sand, their larvae hatched and ready to swim free when the next spring tide returns. Corals around the world, dwelling in darkness far below the sunlit surface, nonetheless release their eggs and sperm on the same night, synchronized to the full moon and the neap tide, a chemical conversation conducted across hundreds of miles of ocean, all orchestrated by light and gravity working together. The moon does more than move water. The moon gives light. On a clear night, when the moon rises full and bright, the darkness retreats. This has been true for so long that it is written into the very being of countless creatures. Nocturnal animals that live their entire lives in darkness have nonetheless inherited an awareness of lunar cycles, embedded in their DNA and their behavior. A moth drawn to light at night is not confused. It is following a compass that points to the moon, using that pale lantern to navigate through a landscape it knows by sensation and memory rather than sight. Many creatures coordinate their breeding, their migrations, their hunts, their hiding, to the moon's waxing and waning. Some animals have eyes sensitive only to the precise wavelength of moonlight. Others possess internal calendars that track the lunar month with the accuracy of an ancient astronomer. Think of what this means, in the deepest sense. For billions of years, nocturnal life did not fear the darkness during a full moon the way it might have during a new moon. The moon's light was protection. It was information. It was an invitation to activity, to mating, to feeding. The moon's absence meant caution, meant the hunting advantage shifted to predators with excellent night vision. This is a conversation older than human language, older than human music, older perhaps than human dreams. Yet we inherited something from it. We, too, feel the pull of the full moon, though most of us have forgotten how to read that signal. Our bodies still measure time by it. Our reproductive cycles echo it. Even in our dreams, the moon appears, a persistent symbol of the night and of mystery, and of tides both literal and metaphorical. The very word month echoes the word moon, the Latin mensis, meaning both month and measurement. Our ancestors could not separate the passage of time from the moon's cycle. They watched it grow from darkness to fullness and back again, and they learned to plant and harvest, to travel and hunt, to celebrate and mourn, in time with that rhythm. The moon was not decoration. It was infrastructure. It was necessity. And here is a gentle, humbling question to consider as you drift further into the night. What would nocturnal life on Earth be without the moon? The darkness would be deeper, the navigation more uncertain. Some scientists wonder whether complex life would have evolved at all on a moonless world, whether the Earth itself would spin differently, its axis wobbling in unstable patterns that would make climate and seasons unpredictable. But we do not have to imagine, because we are fortunate enough to live on a world where the moon has always been there, faithful and steady, pulling the tides, shedding its light, keeping time for all the creatures that have learned to listen to its silent song. The moon has been slowly moving away from us, edging back into space by about 1.5 inches every year, a process that began billions of years ago. The tides will gradually weaken over eons. The days will grow longer as the Earth's rotation slows, the moon's gravity gradually breaking our spin. Billions of years from now, Earth may be tidally locked to the moon itself, if the two remain bound. But that is a story for a far future, so distant that it barely touches the present. For now, in this moment, in this night, the moon still hangs where it has always hung, still pulling, still guiding, still participating in the gentle choreography of a living world. There exists, at this very moment, an angle so precise, so perfectly calibrated, that it has orchestrated the rhythm of human existence for longer than we have known how to measure time. Our planet does not stand upright as it orbits the sun. Instead, it tilts 23.5 degrees, approximately, from the perpendicular plane of its orbit. This tilt, this gentle inclination, is perhaps one of the most consequential accidents in the history of our world, and yet it feels less like accident and more like the universe's gift of balance. Imagine for a moment if Earth stood perfectly vertical, if its axis aligned exactly with the plane of its orbital path around the sun. The planet would receive the same amount of direct sunlight at every latitude throughout the entire year. There would be no seasons, no spring, no autumn. The tropics would remain blazingly hot while the poles froze in perpetual ice, and the vast middle regions where most life has flourished would experience an unchanging sameness. And yet, because of that tilted axis, because of that seemingly small deviation from perfect alignment, our world breathes. It pulses with rhythm. It cycles through transformation. As Earth orbits the sun, a journey that takes exactly 365 and a quarter days, a fact so precise that it shaped our calendar, our holidays, our sense of years, that tilt causes the northern and southern hemispheres to lean alternately toward and away from our star. In the northern hemisphere's winter, when the North Pole tilts away from the sun, daylight hours shrink. The sun's rays strike the surface at a low angle, spreading their warmth across a wider area, delivering less energy to any single point. And then, gradually, almost imperceptibly at first, the planet rotates onward in its eternal ellipse. The tilt begins to shift. The North Pole tilts back toward the star. The days lengthen. The sun climbs higher in the sky. The angle of incidence steepens. Spring arrives. Think about what this means on the most fundamental level. A change in angle, a shift in geometry, transforms light itself. It transforms the very rhythm of day and night across our world. When summer arrives in your hemisphere, you are not necessarily closer to the sun. In fact, Earth's orbit is slightly elliptical, and the northern hemisphere is actually at its farthest point from the sun during its summer. Instead, you receive more sunlight because the angle has changed. The hours of daylight stretch toward 16, 17, sometimes nearly 20 hours near the poles. The sun traces a higher arc across the sky. Its rays strike more directly. And with that directness comes warmth, growth, the explosion of life that defines a season. The beauty of this system, perhaps what makes it so soothing to contemplate in the hours before sleep, is its predictability. There is nothing random about it. The tilt remains stable. The orbit holds its path. Year after year, century after century, the cycles repeat with such precision that ancient peoples, watching the sky, learned to predict the seasons without instruments. They knew, without knowing the mechanisms, that winter would end, that the days would lengthen, that life would return, and this stability itself was not accidental. When that giant impact occurred billions of years ago, when the protoplanet collided with Earth and created the Moon, it left our world spinning at a particular angle and with a particular rotation rate. Over eons, the Moon's gravity has stabilized this tilt, preventing it from wobbling erratically. If the Moon did not exist, if that collision had never occurred, our planet's axis would drift wildly over thousands of years, creating chaotic, unpredictable climate patterns that might have prevented the development of complex life entirely. The Moon, that gentle companion overhead, does more than light the night. It keeps our planet steady. The orbit itself contains a kind of poetry. Earth's path around the sun is not a perfect circle, but rather an ellipse, a gentle oval. The sun sits not at the center, but at one focal point of this ellipse, and this means that Earth travels slightly closer to the sun at certain times and farther away at others. This orbital variation, perigee and aphelion, the closest and farthest points, follows its own rhythm. Yet this too has remained stable, or nearly so, for billions of years. The same distance, the same path, returning eternally. Picture the northern latitudes during summer, where daylight might persist for 18 hours or more. The sun barely dips below the horizon before rising again. Night becomes brief twilight, and the creatures of these regions, both human and animal, experience an abundance of light. Then, half a year later, the same regions experience winter, where daylight might last only 5 or 6 hours, and the nights stretch long and dark. In the tropics, the variation is less dramatic. The sun's seasonal journey across the sky is narrower. The difference between solstice and equinox is more subtle. And yet even there, even at the equator, the cycle persists. The dry season arrives, then the wet. The ocean currents shift. The rains come or cease, according to a pattern millions of years in the making. What is remarkable about this cosmic arrangement is how it creates not just seasons, but possibility. Because of the tilt and the orbit, different parts of Earth experience different conditions at different times. This diversity has allowed life to adapt and flourish in countless forms. Plants evolved to respond to day length, to flower in spring, to set seed before winter. Animals developed patterns of migration, hibernation, breeding, all synchronized to the seasonal clock. Humans, through observation and experience, learned to plant in spring, harvest in autumn, store food for winter, and celebrate spring's return with festivals that echo back thousands of years. The seasons themselves have become more than mere environmental conditions. They have become woven into the fabric of human meaning. We mark time by them. We compose music and poetry about them. We feel them in our bodies. The spring restlessness, the summer energy, the autumn slowing, the winter quiet. And all of this flows from that single angle, that tilt of 23.5 degrees, from the way light and dark distribute themselves according to a mathematical grace. As you lie in the darkness of night, consider that this darkness follows a law. It is not random, it is not chaotic, it is the inevitable result of your position on a spinning sphere, tilted at a precise angle, orbiting at a measured distance from a distant star. The rhythm that has always governed life on Earth continues to govern it still. The seasons will return, the cycle will complete. In that knowledge there is a kind of peace. If you were to stand at the edge of space and look down, you would see something so gossamer thin, so delicate, that it seems almost impossible that it could hold the weight of all existence. The atmosphere, that precious wrapping of air surrounding our planet, is only about 50 miles thick in the places where it matters most. 50 miles. If Earth were an apple, the atmosphere would be thinner than the skin you'd peel away in a single stroke. And yet, within this impossibly fragile veil lives everything we are, everything we've ever known. This thin blue layer, and it truly appears as blue when seen from the darkness of space, is composed of gases arranged in the most elegant hierarchy. Nitrogen and oxygen form the foundation, nearly 4/5 and 1/5 respectively, a proportion so perfectly balanced that you might wonder if it emerged by chance or by some deeper design. Trace elements drift within this tapestry. Argon whispers silently through the upper reaches, carbon dioxide breathes with the forests and oceans, and water vapor rises and falls like the breath of the planet itself. Each molecule plays a role, each layer has a purpose, and together they form something profoundly protective and profoundly peaceful. The lowest layer, where we spend our entire lives, is called the troposphere. It is here that weather weaves its gentle and sometimes fierce patterns. It is here that clouds gather and drift, that rain falls, that wind carries seeds across continents. The troposphere is perhaps 7 to 10 miles tall on average, though it bulges slightly at the equator, as if the planet itself is breathing more deeply there. Within this zone, the air cools as you rise, temperature dropping steadily with altitude. This gradient, this downward cascade of warmth, creates the very circulation patterns that distribute heat across the globe, preventing any single region from becoming too scorched or too frozen. It is a self-regulating system, one that has maintained a livable equilibrium for billions of years. Above the troposphere lies the stratosphere, a realm of stillness and strange beauty. Here, the temperature paradoxically rises again, warmed not by the sun directly, but by ozone, that protective molecule made of 3 atoms of oxygen locked together. Ozone absorbs the ultraviolet radiation that would otherwise sear all life on the surface below. For nearly 4 billion years, as life evolved from simple molecules in the oceans to the complex organisms that would eventually climb onto land, this shield was building, thickening, becoming ever more effective. Imagine the patience of it. Imagine how many generations of ancient organisms had to live and die, had to produce oxygen as a byproduct of their lives, before that protective layer was finally thick enough to permit land-dwelling creatures to walk in sunlight without fear of being burned to ash. The atmosphere is not static. It moves. It dances. Warm air rises near the equator, spreading toward the poles in great river-like currents called Hadley cells. Cooler air sinks at higher latitudes and slides back toward the equator at the surface. This circulation, called meridional circulation, is so fundamental to Earth's climate that it determines where deserts form, where jungles thrive, where rains fall reliably, and where droughts persist. All of this movement is silent, invisible to the eye, yet you feel it on your face with every breeze. The wind you encounter is simply the atmosphere doing what it has done for millions of years, redistributing heat, balancing energy, keeping the planet in a state of graceful equilibrium. What is perhaps most soothing to contemplate is that this atmosphere is not merely a passive shell. It is a participant in the dance of life itself. Every breath you take draws in oxygen that was released by plants and phytoplankton over millions of years. Every exhalation releases carbon dioxide that feeds those same organisms. This cycle has been turning for so long that it has become almost meditative in its repetition. The atmosphere remembers the dinosaurs. It has carried the spores of ancient ferns, the pollen of flowers that no longer exist, the ash of volcanic eruptions that reshaped continents. And yet, with each passing year, with each new generation, it renews itself. The pressure of this atmosphere, the weight of all those molecules stacked above us, is something we are so accustomed to that we never notice it. At sea level, that pressure amounts to about 14 pounds per square inch on every surface. It is as if you are being gently held, cradled by the very air you breathe. This pressure keeps the oceans from evaporating entirely. It allows sound to travel on invisible waves. It supports clouds, carries birds, permits the very sensation of wind on skin. Remove this pressure, and the world would become instantly silent, instantly alien, a barren landscape beneath a black sky. And yet we move through it without thinking, unaware of this constant embrace. There is something almost tender about the relationship between the atmosphere and the life it protects. The ozone layer shelters us from radiation while being damaged by certain chemicals that humans released into the air. Chemicals that persisted for decades despite the damage they caused. And yet the ozone heals. It has begun to repair itself. Slowly, gradually, because humans recognized the problem and chose to change their behavior. The atmosphere, fragile as it is, has proven remarkably resilient when given the chance. It is a reminder that what is delicate need not be disposable. What is thin need not be weak. What is vast need not be invulnerable. But it is capable of remarkable self-repair when treated with care. As you drift towards sleep, consider the simple fact that the sky above you, that expanse of blue during the day, that canvas of stars at night, is not empty. It is full, it is alive, it is the very thing that stands between you and the harsh vacuum of space. And it does this work in silence, in perfect, undramatic calm, asking for nothing in return but the simple act of life itself, the breathing, the growing, the being that all creatures do naturally. The atmosphere asks only that we exist. In return, it grants us everything. And yet, there is something even more calming to contemplate than the slow drift of continents or the steady hum of magnetism around our world. Something we can witness in miniature every single day if we only pause to notice it. The water cycle, that endless, patient circulation of moisture that has been moving across Earth's surface for more than 3 billion years, in virtually the same rhythm, the same gentle choreography, repeating itself again and again, without cessation or complaint. Imagine, if you will, a single molecule of water, not as a concept, but as something real and ancient, older than civilizations, older than mountains, older than the species that now drink from it and bathe in it and weep into it. This molecule has journeyed everywhere on Earth. It has fallen as rain on the Amazon basin, evaporated from the Sahara, condensed into snow on the Himalayas, flowed invisibly through the roots of a redwood forest, risen as mist from the Dead Sea, and it will continue to journey, in an endless loop, for as long as the sun warms our planet. The cycle begins in stillness. Water rests in the oceans, covering more than 70% of Earth's surface, sitting in that vast, stable embrace of blue. And there, beneath the soft caress of sunlight, it begins to transform. Evaporation, that gentle uprising of water molecules from liquid to vapor, pulls moisture from the sea's surface. Not violently, but gradually, continuously, so slowly that we do not see it happening. And yet, if you have ever stood near the ocean on a warm afternoon or watched a puddle disappear without rain, you have witnessed this quiet alchemy. Water becomes weightless air, rising invisibly into the atmosphere, carrying with it a kind of freedom. But there is also another, quieter form of evaporation, from the soil, from lakes and rivers, from the leaves of plants themselves, in a process called transpiration, a soft exhalation of moisture that forests and grasslands release into the air as they breathe. Combined, evaporation and transpiration move approximately 1 trillion tons of water into the atmosphere each day. Think on that for a moment. 1 trillion tons, rising gently, continuously, like a slow exhalation from the planet itself. And where does all this vapor go? It does not scatter. Instead, it rises and cools. As it ascends into higher reaches of the atmosphere, where the air grows thinner and colder, that invisible vapor begins to lose energy. It condenses, transforming back into liquid, but now in microscopic form, droplets so small they float suspended in the air. These infinitesimal spheres cluster together, and together they form clouds, vast, drifting formations of water, shaped by wind and light, hanging in the sky as if by some invisible thread. A single cloud might contain millions of tons of water, and yet it floats. This is one of the great paradoxes of our planet, one of the deeply comforting mysteries, that something so heavy can be made so light by the simple process of transformation. The clouds drift across the sky, carried by currents of air, sometimes for thousands of miles. They change shape as they move, breaking apart and reforming, constantly renewing themselves. And if you have ever watched clouds from the ground, or from an airplane, or from the imagination before sleep, you know the profound peace that comes from simply observing this slow, aimless wandering. But the clouds do not remain aloft forever. As they drift and encounter cooler air, or as water droplets continue to cluster and grow heavier, something remarkable occurs. The vapor condenses further, the droplets merge, and then, finally, they can no longer remain suspended. Gravity calls them home. They fall. Rain, that most ancient and essential gift that has sustained every living thing on Earth since the first molecules of water condensed in our young planet's early atmosphere. Rain falls gently on mountains and deserts, on forests and cities, on fields of grain, and on still ponds. It patters on leaves, it drums on rooftops, it creates temporary rivers in the dust. And in this falling, water returns to the land, to the soil, seeping downward in a patient percolation, moving through layers of earth and stone, replenishing aquifers that have held water for tens of thousands of years. Some of this water is absorbed by roots. Plants draw it upward through their vascular systems, using it to grow, to photosynthesize, to live. Animals drink from streams and puddles. Humans gather it in wells and reservoirs. And all of it, eventually, begins the journey again. The water that falls as rain will evaporate once more. The water that is drunk by a deer will transpire from the deer's breath and skin. The water that nourishes a forest will rise from the soil and be released by the leaves. And then there are the rivers, those flowing arteries of the land, gathering water from countless streams and tributaries, moving it downward always, following the gentle slope of the terrain. A river is water in motion, but even in motion it is calm. It does not rush without reason. It follows its channels, carved over millennia, sometimes meandering in great loops across plains, sometimes cascading rapidly over stones, but always ultimately moving toward the sea. The sound of a river, the soft murmur and gurgle of water flowing over rocks, is perhaps one of the most fundamentally soothing sounds our ears can perceive, something our brains recognize as essential and safe. Rivers carry more than water. They carry sediment, minerals, nutrients accumulated from the land. They flow through canyons and valleys, past villages and cities, supporting not just human life, but the entire ecosystem that depends on their flow. And they are ancient pathways. The same rivers that flowed through the lands where human civilization first emerged still flow today, carrying water and memory and connection between past and present. And finally, after traveling through streams and across vast distances through rivers, the water returns to the ocean. It merges with the collective vastness, joining that enormous reservoir of salt water that covers our planet. Here, the cycle begins again. The water that fell as rain days or weeks or months ago now rests in the sea, and the sun warms it once more, calling it upward into vapor, beginning the patient journey anew. This cycle is relentless and eternal. It has no beginning and no ending, or rather, it has been beginning and ending continuously for billions of years. Every water molecule on Earth has cycled through this pattern countless times. The water you drink may have been part of an ancient ocean, been released as vapor from a dinosaur's breath, fallen as rain on a Neanderthal's shelter, flowed through the rivers of Rome, risen as mist from a Japanese garden. It is impossible to know, and yet it is perfectly, beautifully certain. And here is what makes this cycle so deeply soothing to contemplate. It is balanced. Despite all the chaos and unpredictability of human existence, despite droughts and floods and storms, the water cycle maintains an equilibrium. The same amount of water that evaporates eventually falls as rain. The same amount that flows into the ocean eventually rises again as vapor. Our planet has achieved this balance not through intention or control, but through the simple, inevitable physics of matter and energy, through billions of years of operation. In some way, we can trust this cycle. We can rest in the knowledge that water will continue to fall, to flow, to return to us. The clouds will continue to form and drift and empty themselves over the lands. The rivers will continue to run. And all of us, whether we are aware of it or not, are part of this cycle. The water that is part of your body right now, in your blood, in your breath, in the moisture of your eyes, has been and will be part of clouds and oceans and rain. You are, in the most literal sense, composed of the same water that has been circulating through this planet for eons, and that water will continue to circulate long after you are gone, moving through other bodies, other plants, other creatures yet unimagined. There is profound peace in recognizing yourself as a temporary custodian of something eternal, in knowing that you are not separate from this cycle, but woven into it, part of the great circulation that sustains all life. The water cycle is not something that happens to Earth. It is something that is Earth. It is one of the defining characteristics of our living planet, the rhythm that keeps everything in motion, in balance, in continuation. Close your awareness around this idea for a moment. Let it settle gently. The cycle continues, has always continued, will always continue. Rain falls, rivers flow, the ocean breathes, and in this endless, patient circulation, we find not chaos, but the deepest kind of order, the order that emerges not from rigidity, but from the simple, eternal nature of matter, transforming itself again and again, forever returning to itself. There is a peculiar threshold that astronauts describe, a moment so profound that it has altered something fundamental in the consciousness of everyone who has crossed it. It arrives sometime during the first hour of ascent, when the curve of Earth becomes visible against the black of space, when the planet transitions from a place you inhabit to an object you can hold in your eye. Dozens of people who have traveled to orbit, to the moon, to the depths of space, speak of this moment with a language that borders on the spiritual, though many of them struggle to find words adequate to the experience at all. What they describe, again and again, is peace. Not the absence of wonder, but something that sits alongside the wonder, like two notes held together in perfect harmony. There is the shock of seeing a place so vast, so impossibly intricate in its patterns of cloud and ocean and light, and yet so small that you can block it from your eyes with your thumb. There is the strange sensation of weightlessness, of floating, of being cradled by nothing and held by everything simultaneously. But what seems to settle most deeply into the minds of those who have traveled beyond is a recognition of profound stillness. Astronauts speak of how, from that vantage point, Earth appears to be sleeping. The continents rest in their slow, glacial movement, unaware of how their drift is perceived across geological time. The oceans hold their color, a blue so saturated and absolute that it seems almost impossible that such a hue could exist in nature. The atmosphere, which from the ground feels infinite, reveals itself as gossamer thin, a delicate membrane of molecules barely clinging to the planet's surface, catching and scattering the light of the distant sun in ways that create halos and glows of almost unbearable beauty. One astronaut, who spent nearly a year aboard the International Space Station, described Earth at night as the most calming sight imaginable. City lights trace the coastlines, and major valleys, like bioluminescent organisms in a dark ocean. The lights themselves move slowly, following the rotation of the planet in a rhythm so patient, so measured, that watching them induces a state of almost meditative stillness. The vast dark spaces between those lights represent oceans, deserts, mountains, forests, empty spaces, quiet places. The astronaut remarked that there is something deeply soothing about the knowledge that so much of Earth remains dark and undisturbed, that wilderness still exists in abundance across the planet, even as civilization spreads its illumination across certain portions of the sphere. Another explorer who traveled to the moon itself offered perhaps the most oft-quoted observation of Earth from space. He described it not as a world of borders and nations, not as a stage of human conflict or achievement, but as a single, coherent entity, a precious thing, a blue marble. The term has become something of a cliché, but clichés often persist because they express something true that cannot be improved upon by elaboration. From that distance, the political boundaries that seem so consequential on the ground become invisible. The mountains and rivers that divide nations appear as they truly are, as features of a shared landscape belonging to every living being on the planet simultaneously. There is something profoundly settling about this perspective, a gentle leveling of human concern that can only come from stepping outside the atmosphere entirely. What astronauts almost universally report is that this view changes something about how they understand their place in the cosmos. Not in a jarring way, but in a manner more like the slow dawning of evening, when light gradually gives way to darkness without a single moment of abrupt transition. They return to Earth with an altered sense of what matters. Many speak of a kind of cognitive shift toward thinking of themselves as crew members on a single spacecraft, all dependent on the same life support systems, all hurtling together through the vacuum at tremendous speed. This perspective, rather than feeling frightening, seems to comfort them. There is solidarity in it. There is a reassurance in being part of something so unified, so continuous, so whole. The photographs that these travelers have brought back, thousands upon thousands of images of Earth taken from orbit, from the moon, from rovers on other worlds, all serve as a kind of visual testimony to this peace. In these images, Earth is almost always depicted in color, in light, in motion. Yet there is a stillness captured in every frame. The storm systems that swirl across the oceans are rendered beautiful rather than terrifying. The deserts that stretch across continents appear as patterns of ochre and gold, intricate and ancient. The polar ice caps hold their brilliance, white and serene, untouched by distance or void. What might surprise you is that this piece is not merely a product of perspective, though distance certainly contributes. Rather, it seems to emanate from the planet itself, from the billion years of slow stabilization, the magnetic field humming its invisible protection, the rotation maintaining its steady rhythm, the orbit keeping its careful pace around the sun. From space, an observer can sense the deep habitability of this world, the way it has persisted, evolved, and maintained its gentle systems across incomprehensible spans of time. There is comfort in that durability. There is rest in the knowledge that you stand upon something so ancient, so proven, so fundamentally sound in its basic operations. The poets among the astronauts often speak of their experience in language that sounds almost like prayer. They describe Earth as a sanctuary. They speak of its colors with tenderness. They recall the sensation of floating in darkness and looking back to see that single beacon of life and light, and finding in that moment a kind of answer to questions they may not have known to ask. Did they feel less alone? Did they feel more connected? The language varies, but the emotional truth remains consistent. Earth, seen from the remove of space, offers a vision of peace that seems to settle into the body the way moonlight settles on still water. There is something almost imperceptible happening to the Earth right now, as you listen to these words, something so slow that no human has ever felt it in their bones, yet something perfectly real and measurable. The planet is spinning just a fraction slower than it was yesterday. The day is becoming, grain by grain, fractionally longer, and this has been true for billions of years. When the Earth first formed, spinning from the collision and settling of cosmic dust, it rotated far more quickly than it does today. Ancient days were shorter. A day in the early Earth, perhaps 4 billion years ago, may have lasted only 18 hours. The planet spun faster then, a young thing with all the angular momentum of its formation, still rushing through its core, still singing with the energy of its own assembly. But something has been slowing it down, as patient and inevitable as gravity itself. That something is the moon. Every time the ocean tides rise and fall, drawn up by the moon's eternal pull, there is a subtle friction, water moving against the ocean floor, that immense mass of liquid shuffling back and forth across the planet's surface creates drag. And where there is drag, there is a gentle loss of energy, not a violent loss, not something you could ever notice, but a constant, patient removal of rotational momentum. The Earth spins a tiny bit slower each time the tides turn. Each day grows longer by a fraction of a second. This process, occurring over periods of millions and billions of years, has already lengthened our days considerably. Between the time the dinosaurs walked the Earth, roughly 65 million years ago, and today, the day has grown longer by approximately 1 second. Just 1 second in all that time. But extrapolate backward into the deeper past, and the effect becomes more dramatic. 3 billion years ago, days on Earth were perhaps between 20 and 22 hours long. The Earth was spinning like a top wound, tighter, faster, more urgent. Life in those ancient oceans would have experienced a slightly different rhythm of day and night, a faster tumble through light and shadow. What becomes fascinating, when you think about it truly, is that this slowing continues still. Right now, at this very moment, the day is becoming infinitesimally longer. Scientists who study these things with extraordinary precision, measuring time through atomic clocks so accurate they would not lose a second in billions of years, have calculated that each day grows longer by approximately 1 to 2 milliseconds every century, 1 to 2 thousandths of a second per 100 years. It is so small that your lifetime will encompass only a fraction of a second's change, and yet it is real. It is happening. The mechanism is beautiful in its simplicity. The moon pulls at the Earth's oceans with a gravitational caress that is always there, always tugging. The oceans respond by bulging toward the moon, by rising and falling in that great rhythm that has guided so many creatures, including humans, for eons. But because the Earth rotates faster than the moon orbits it, the tidal bulge is carried slightly ahead of the moon's position. This dragged forward bulge then exerts a backward pull on the moon, very gently, very steadily, causing the moon to spiral slowly, infinitesimally outward in its orbit, away from us. In exchange, the Earth's rotation slows. Energy is transferred from the Earth spinning to the moon's orbital motion, like two dancers leaning into each other in an ancient choreographed waltz. The moon, as a result, is moving away from us. Each year, it drifts about 3.5 centimeters farther from the Earth. Given enough time, and we are speaking of tens of billions of years in the far future, the moon will be so distant that it can no longer trigger the tides as it does now. The days will have grown so long that one side of the Earth will be permanently facing the moon, locked in what is called tidal locking. But that is a story for a future far beyond human concern. For now, for the vast stretches of human history and prehistory, the slowing has been so gradual as to remain almost completely hidden. Our ancestors never felt the days growing longer. The change occurs at a scale that requires instruments and mathematics to detect, a scale that belongs to geology and astronomy rather than to the immediate sensation of living. And perhaps there is something deeply soothing in that knowledge. The planet is changing, yes, but it is changing so slowly, with such patient inevitability, that there is no anxiety in it. It is not catastrophe. It is simply the gentle, continuous rearrangement of a system so immense that its transformations occur on the calendar of stars. Think of it this way. In the time it takes you to draw a deep breath and exhale, the Earth continues its slowing. In the time it takes you to fall asleep, the day has grown fractionally longer. In your entire life, you might experience just a few hundredths of a second of this accumulated change, and you will never sense it. But your great-great-great-grandchildren, separated from you by enough generations and enough time, might inhabit a world where the day has lengthened by measurable amounts. They will not feel it either, because the change will be so smooth, so integrated into the rhythm of their existence, that it will simply be their normal. This is the deep rhythm of the Earth, the breath of planetary mechanics at a scale so vast that it humbles human time. The Earth is not agitated. It is not anxious about its slowing rotation. It simply continues, turning through space, shedding angular momentum to the moon, like a top losing its spin as it ages. And in doing so, it reshapes the very fabric of days and nights for any life that exists upon it. There is no urgency here, no rush. Only the patient, inexorable passage of cosmic time. Since we began detecting worlds beyond our solar system in 1995, astronomers have discovered more than 5,000 exoplanets orbiting distant stars, 5,000 separate worlds, each one circling its own sun in the dark. And yet, among all of these distant spheres turning through the cosmos, Earth remains profoundly, quietly singular. Consider what we know. The vast majority of exoplanets discovered so far are either massive gas giants that dwarf Jupiter, or dense, scorched rocky worlds that orbit so close to their stars that any surface would char into lifeless ash. The sweet middle ground where Earth resides, a rocky planet of moderate size, orbiting at just the right distance from its star, spinning steadily on an axial tilt that creates seasons. This configuration is far rarer than we might wish to imagine. It is as though Earth landed in a narrow golden band of probability, almost by accident, and few others have followed. We call this habitable zone the Goldilocks region. where temperatures might allow liquid water to pool and persist. Not too hot, not too cold, just so. But the habitable zone is only the beginning of Earth's improbable collection of gifts. A rocky exoplanet in the correct orbital position means nothing if it lacks a protective magnetic field to shield it from stellar radiation. Most detected terrestrial planets appear to have lost or never developed such a shield. Their atmospheres have been stripped away by solar wind over billions of years, leaving bare, desiccated surfaces where nothing stirs. Earth's magnetic field, that gentle humming invisible dome we have already contemplated, is itself unusual. It requires a dynamic iron core, a planet massive enough to retain heat, and specific conditions of rotation and planetary composition. Not all rocky worlds possess it. Many that might otherwise be habitable have been rendered sterile by this single missing ingredient, the absence of protection. Then consider the Moon. Our satellite is not merely a companion in the night sky, decorative and peaceful though it undoubtedly is. It serves as a stabilizer, holding Earth's axial tilt at a moderate angle through the gravitational conversation between our two bodies. Without it, Earth's tilt would wobble wildly over tens of thousands of years, swinging from near vertical to nearly horizontal relative to the plane of its orbit. The climate would convulse. Ice ages would arrive and vanish with chaotic violence. The very stability that allows complex life to persist and evolve would evaporate like morning dew. How many exoplanets possess such a large, stabilizing moon? Few indeed. Most planets studied lack satellites entirely, or carry only small, distant moons that offer no protective gravitational embrace. There is another aspect that renders Earth subtly unique, one that astronomers now recognize as essential: the presence of plate tectonics. Our planet's crust is broken into fragments that move, collide, slide past one another, and recycle slowly into the mantle. This endless gentle grinding maintains a stable climate over geological time. Volcanic outgassing replenishes the atmosphere. Rock weathering absorbs carbon dioxide. The system adjusts and rebalances across millions of years, buffering against runaway climate extremes. Not all rocky planets have active plate tectonics. Some are too small and have cooled internally, their surfaces locked into stillness. Others may possess a crust too dense or poorly fragmented to move. Venus, our sister planet, appears to have halted its tectonic activity billions of years ago, and now its surface bakes under a suffocating, runaway greenhouse atmosphere. Earth, by contrast, continues its slow rhythmic breathing, its continental dance, maintaining the conditions that life requires. When we gaze outward at the catalogued exoplanets and consider Earth among them, what emerges is not arrogance, but a kind of awed humility. The rarity of a world like ours is becoming clearer with each new discovery. The convergence of factors, a star of the right age and temperament, an orbital distance that permits liquid water, a rocky composition, a sufficient mass to retain an atmosphere and generate a magnetic field, a large stabilizing moon, the slow turn of plate tectonics. These form a pattern that appears to be statistically improbable, not impossible, not even inexplicable, simply rare. There may be other worlds out there where this exact combination has aligned. The universe is unimaginably vast, and 5,000 known exoplanets represent merely the faintest fraction of what must exist in the darkness between stars. Perhaps dozens or hundreds or thousands of other Earths circle distant suns, harboring their own oceans and their own stories. But we do not know them. We have not touched them. They remain beyond our current reach, folded into the silent geography of deep space. What we do know is this world, this particular sphere, this specific arrangement of stone and water and air and fire, turning in its orbit with all the weight of biological and geological history layered into its every surface. Earth is common in the universe, only in the sense that planets themselves are common. As a habitable world, as a place where the conditions align in such delicate, improbable arrangement, Earth is rare. Consider the perspective of an astronaut viewing Earth from orbit, a vantage most humans will never know. They see a single marble of blue and white and subtle greens, swirled with clouds and ocean currents. They see no borders, no nations, no grand monuments or cities from that distance, only the soft curve of a world held in darkness, protected by its thin atmosphere, turning steadily in the void. And almost universally, those who have witnessed this view report a profound shift in consciousness. The Earthrise photograph from Apollo, the testimonies of cosmonauts and astronauts who have looked upon our planet from beyond its sky, they speak not of triumph or dominion, but of fragility, of beauty, of belonging to something larger and older than individual lives or nations. This is Earth's place in the galaxy. Not the center, not the only habitable world in the cosmos, but distinctly, quietly, its own thing. A rare configuration, a gentle world, a home that required billions of years of patient cosmic work to bring forth, and that might well never be precisely replicated in all the sweeping arc of time and space. And so we arrive at the farthest reaches of our contemplation, where time stretches out before us like an endless horizon, where the story of Earth continues onward into epochs we will never witness, into a future written not in the anxious present, but in the slow mathematics of stellar aging and planetary drift. The Earth, this blue stone that has cradled life for nearly 4 billion years, is not eternal. Nothing is. But the manner of its ending is not catastrophic or sudden. It is gradual, patient, almost gentle in the way that only cosmic time can be. The sun, that constant companion that has burned faithfully above our heads since before the first humans walked upright, is aging, not visibly, not in the scale of human lifespans, but measurably, inevitably. Every second, every moment of every day, the sun is slowly, methodically burning through its hydrogen fuel, fusing it into helium in its core, converting mass into energy, in a process that has continued for 4.5 billion years. In another 5 billion years, perhaps 5.5, the sun will begin its transformation into what astronomers call a red giant. This is not an explosion or a sudden cataclysm. It is a slow, inevitable expansion, as if the star itself is taking one last, long breath before beginning its final chapters. When this happens, the sun will swell. It will grow larger and larger, its surface creeping outward, its luminosity increasing. The Earth's orbit will remain stable in the gravitational sense, but the thermal landscape of our world will shift so profoundly that all life, as we know it, will have long since transformed or vanished. In perhaps 1 billion years before the sun reaches its most extreme expansion, the oceans will begin to evaporate more intensely than they are replenished by rain. The atmosphere will grow hot and thick with water vapor. The delicate balance that has allowed life to flourish will begin to tip toward an uninhabitable extreme. And yet, even in this process, there is a strange, sorrowful beauty. The Earth will not simply disappear. It will change, gradually, like a sunset that lasts for millions of years. The precise fate of Earth itself remains somewhat uncertain, even in scientific terms. Will the planet survive the sun's expansion? Will it be consumed in the outer layers of the swollen star, dragged inward by gravitational forces and digested in stellar plasma? Or will it escape, pushed outward by radiation pressure, drifting into the cold dark as an orphaned, lifeless sphere, circling the dead remnant of our star, a white dwarf no larger than Earth itself, but containing nearly all the mass the sun once held? The truth, it seems, is that we cannot yet know with absolute certainty. The dynamics are complex. The future is written in probabilities and estimates rather than certainties. And there is something almost comforting in that uncertainty, in the notion that the cosmos keeps some of its secrets even from our calculations. But consider for a moment what this means. Consider the sheer span of time that lies between now and then. 5 billion years is almost impossible for the human mind to grasp. It is longer than life has existed on Earth. It is longer than complex life, longer than dinosaurs, longer than mammals, longer than primates and humans, and all of recorded history put together. And yet that vast expanse is merely the twilight of our planetary story. The Earth was formed from stellar dust. It has turned in silence and light for billions of years. It has warmed and cooled, borne mountains and worn them down, created oceans, and allowed them to birth life itself. And it will continue, changed but existing, until the final chapter of its star closes. What does it feel like to contemplate such vastness? What emotion arises when we consider that our home is not fixed in some eternal state, but is, like everything, moving through time toward transformation? Perhaps there is a kind of relief in it. The pressure we feel to preserve the world, to keep it exactly as it is, softens slightly when we remember that the world has always been changing, is always moving, always becoming something new. The Earth itself teaches us the practice of letting go, of transformation, of surrendering to time's patient flow. In the meantime, in these brief moments that are our lives and our civilization, the Earth spins on. The continents continue their slow continental drift, moving imperceptibly across the surface of the world, bumping and grinding against one another in their geological dance. Mountains rise and erode, seasons turn, the moon gradually drifts farther away, receding from us at the rate of a few centimeters per year, a farewell that will take billions of years to complete. And we, conscious and aware, exist in this moment, between the planet's ancient past and its distant future, able to perceive both, able to marvel at the quiet majesty of it all. There is no urgency in cosmic time. There is only continuation, transformation, the slow unfolding of physical law across billions of years. The Earth does not hurry toward its destiny. It will not rush into the future. It will move at the same steady pace at which it has always moved, rotating on its axis, orbiting its star, spinning through the galaxy like a dancer who knows the steps by heart, having performed them countless times before. And in that steadiness, in that refusal to accelerate or panic, there is something almost like a lullaby. The Earth hums its song of patience. It teaches, to those who listen, the art of endurance and the peace that comes from accepting the vast, inevitable arc of time, knowing that all things that rise must eventually transform, and that the transformation itself is written into the nature of existence itself. And so we return, at last, to where we began, to that slowly rotating sphere of blue and brown and white, turning in the patient silence of space, completing one full revolution every 23 hours and 56 minutes, a rhythm so constant it has become the very heartbeat of time itself for everything that lives upon its surface. Look at it, turning there, beneath the infinite dark. The sunlight slides across it in that same gentle way it has for 4.5 billion years, a slow, inexorable carousel of light and shadow, of dawn and dusk, painted across mountain and ocean, across ice and desert, and the green pulse of forests that have learned, over time, to breathe in rhythm with the turning world. There is something profoundly settling about this image. The Earth, you see, is one of the rarest things in all we have come to know of the cosmos. Not because it is unique in every detail, there may well be others like it, drifting around distant suns, in quiet neighborhoods we have yet to visit, but because it is precisely balanced, because everything on it has had enough time, enough stillness, enough constancy to learn to thrive together. The moon hangs above it, as it has hung, pulling gently at the tides, stabilizing the tilt, casting that soft light that guided the first creatures from water into night. The magnetic field hums silently around it, turning aside the solar wind. The continents have drifted into configurations that allow for oceans and mountains and the slow whisper of plate tectonics. The atmosphere floats above it like the gentlest of veils, thin enough to let the starlight through, thick enough to hold warmth and breathe. And within all of that, within every layer and system and delicate balance, there is rest. Not the rest of stillness. The earth never truly stops, and nor should it, but the rest of rhythm, of cycles, of things that know their place and return to it again and again, as reliably as you might return to sleep each night. The water falls as rain and rises as vapor and flows as rivers and spreads across oceans and falls again. The seasons turn, and the light lengthens and shortens, and living things know how to respond. The days grow imperceptibly longer, but over the course of your own lifetime, or 1,000 lifetimes, this change is so slow as to be invisible. You will never notice it. Your children will not notice it. The earth has given us the gift of constancy, the gift of time that moves at a pace we can bear. Think of what the astronauts have said, drifting above it in that profound silence of space, looking down at the thin atmosphere, protecting everything they have ever loved. They speak of awe, yes, of wonder, but they also speak of something quieter, something like coming home, something like the deepest peace. Perhaps it is because we are made of this. The calcium in your bones came from ancient oceans. The iron in your blood was forged in the heart of a dying star, and brought here on a meteorite, and became part of the earth, and became part of you. You are not separate from this turning world. You are woven into it as intimately as the root is woven into soil, as the water is woven into cloud. Every breath you take is a breath the earth has taken, and will take again. Every heartbeat echoes the slow pulse of its rotation. And so when you rest, when you allow your eyes to close and your breath to deepen, and your mind to drift into that first gentle dark, you are doing what everything does. You are aligning yourself with the rhythm that has held this planet steady for billions of years. You are moving with the slow turn of the world. You are resting in the cradle of something ancient and patient and profoundly, quietly alive. The earth will continue to turn. It will turn while you sleep. It will turn while you dream. It will turn while your heart slows and your body surrenders into rest. And when you wake, it will have turned you somewhere new, just slightly, just infinitesimally, but always forward, always into the next moment, always into the soft light of another day. There is no urgency here, no hurry. The earth has billions of years left before it begins its long, slow aging toward the end. You have all the time you need, all the rest you can possibly hold within this rare, this fragile, this impossibly beautiful moment of stillness. Let the image hold you, the slowly turning sphere, the light crossing it, patient and eternal, the thin atmosphere glowing at its edge like a halo of breath, the continents in their slow, imperceptible dance, the oceans keeping their ancient rhythm, the moon watching over it all. This is where you are. This is what holds you. This is the quiet, perfect place where rest lives. And as the world turns, and the shadow deepens across one hemisphere, and the stars emerge in their countless, patient multitudes, know that you are turning with it. You are part of it. You are held by it. Drift now, gently, down into the dark, down into the deep. The earth turns on. The rhythm continues. And in that continuity, in that perfect, ancient pulse, there is nothing to fear, only rest, only the slow, steady turning of home.